Welcome to the MassMotion version 8 tutorial. In this tutorial, we will have a look at the different ways we can schedule agents to move throughout our scene. There are 5 ways we can do this in MassMotion, ranging from simple to increasingly complex. These are located here under the Activities tab. We've already seen the Journey event, which enables movement from one place to another. We will have a look at the Circulate event, which allows movement from an origin to a destination with intermediate points. We can also have a look at the Vehicle event, which can act as a proxy for train or bus movements. The Evacuate event, which allows modelling of fire egress and other egress scenarios. And the Timetable event, which allows advanced manipulation of schedules. To start off with, let's have a look at the Circulate event using one of the pre-installed examples. What we see before us is a simple model that represents a mall with some parking. This portal represents parking external to the facility, and then there are, if we look in the list, there are 4 stores here, 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 and here. What we would like to do is have people enter from the parking, move throughout this facility, and then eventually exit the way they came. In order to do that, there is an existing Circulate event, which we will look at in detail. Opening the Circulate event from the list view, we see that there are several tabs. The first governs where agents will start and finish, and how many agents will be created. As we can see, the timing starts at t=0. We have a default profile, and we are creating 300 agents over 10 minutes. As with every piece of demand scheduling in MassMotion, there are several ways in which we can spread these agents out over a given duration, such as uniform, normal, triangular, and others. As stated previously, we have our agents beginning at the parking level and moving through the scene. We also want them to go back to the parking when they're finished. In terms of the agents circulating around, we look at the Circulate tab within this ribbon. There are several ways in which agents can circulate within this scene. They can do this for either a set period of time or a number of cycles, effectively. For now, we'll use a combination of duration and count, and the agents will, based on which of these tasks they create first, then head to their chosen origin. For now, we will say a uniform distribution with a minimum of 5 minutes and a maximum of 10, and moving to each of these portals from between 1 to 3 times. We can set which portals each agent goes for. We can also have these equally weighted or with a set manual weight. Since this store is considerably larger than the others, we can bias that to have more agents wait in here. We do this by selecting manual weights, and we can effectively bias this by setting certain values for each store. We can then normalize with this button, which will round all of our percentages. We now have half of all agents moving up to this portal whenever they are circulating. In order for our agents to wait within each one of these stores, we also have the Dwell tab. This will allow us a duration of agents to stay within each of these portals as soon as they've touched them. For now, we will have a uniform wait from 30 seconds to 2.5 minutes. We also have standard systems such as colors of agents and potential actions, which we'll discuss later. In order to have a look at this behavior, let's run the model now and see what we see. So if we run the simulation, set a working folder, and we will call this our Circulate event. We should see our peak population at 10 minutes when all of our agents have been created, and then we will see agents slowly leave the model after they've finished circulating. Having a look at this, zooming in with our S key, we see agents entering the model and waiting at each of the portals, and then after 10 minutes has passed, we should see some agents start to leave the model after they've finished circulating between each of these portals. This gives a brief overview of the Circulate event we can have a look at some other scheduling events, such as the vehicle and evacuate. Let's look at those now. The next event that we will look at is the evacuation event. To start off with, let's use the previous example that we've looked at in the past with our mall. Opening it up, we have the same geometry, but this time what we want to do is evacuate this area above the stairs and tell people to, after a certain period of time, leave this area and head to one of our exits. In order to do that, we use the evacuate event. Having a look at the properties of the evacuate event, we have the same style of agent tab, which includes a time in which this will start, and also the amount of agents that will be created. We also have our distribution of origins as before. We will have half of all of our 100 agents arrive at this portal. In order to get our agents to evacuate, we will look at the evacuate ribbon. This will have a timing at which agents are told to evacuate, the zone from which they will evacuate from, and any exits that they will evacuate to. Our time can be a single point in time, or it can be a distribution to show agents reacting to things such as sirens or signage over a given range of time. For now, we have a minimum of 15 seconds, an average of 30 seconds, and a maximum of 1 minute. In terms of where our agents will be told to evacuate from, we have something called a zone. A zone is a type of collection in MassMotion that will be a group of objects. Having a look at the zone in the list menu, we see that it includes both of these floors. This will mean that anyone standing on either of these floors at the given time of the evacuation event will be forced to leave the zone. So if we move that, we now see that any agents within this zone will be sent to either our parking lot exit or also this emergency exit. In order to do so, they will take the first available option and then just take the most efficient route to either one of these. This checkbox denoting clear route history means that agents will not be penalized for backtracking, heading back away they come, or basically telling them that they just need to leave as efficiently as possible. Let's have a look at how this works in practice. We will run the simulation. As before, we should see our 100 agents leave the scene quite effectively. So as we see our agents are forced to leave this scene over the period of 1 minute and evacuate to either their closest one of these two exits. This gives a brief overview of the evacuation event within MassMotion. Next up, let's have a look at the vehicle event. That we will look at is the vehicle event. This enables us to model things such as bus or train arrivals. Let's have a look at one of our previous examples, the transit hub. This is more in line with the complexity in terms of operations and geometry of a standard small MassMotion project than previous examples. What we have here is some street level geometry with some neighborhood portals at the ends of each street. We also have a small bus facility here with several bus drop-off points, and also a train underground that has eastbound and westbound platforms. In order to populate this scene with agents, we have several vehicle events. These include a bus arrivals event for the bus system, and also eastbound and westbound trains. We also have an overall simple journey event showing different neighborhood portals moving through to our train system. In terms of our other events, we also have the open gate event, which we can take a very quick look at. This governs what's going on at our crosswalks to simulate things such as traffic signals. What we have here is all of the east-west crosswalks in the scene links have been gated, and then we have within our open gate event a timing range that says that each of these gates are open for 30 seconds and then closed for 45 seconds. This will enable red signals to be used, so agents will wait at the crosswalks to move across at grade before then moving down to the train station. In terms of our slightly more complex vehicle events, let's have a look at one of the train schedules. Here inside the vehicle event, we have several tabs within our ribbon. First off, we have the vehicles themselves, including headways and what we consider to be the actual interface between the vehicle and the rest of the scene. Here we say that our first train arrival is at the start of the simulation, and we're saying that we will have multiple arrivals according to the following headway timing. This says that we will have a headway of a range between 3 minutes and 20 seconds and 3 minutes and 40 seconds. This can be an explicit value, explicit constant value, and also a distribution to take into account things such as late train arrivals. We also set a dwell time for when the train is within the station. For now, we've said 30 seconds. What this dwell time governs is which of these links that we have in our vehicle doors list will open and allow agents to basically alight or board the train. In terms of generating our alighting agents, we can create a population here. So here we have 100 agents, which will start at predetermined lists and head to our neighborhood exit. What we see here is a collection, which is a group of objects similar to our zone from the previous example. A collection can have multiple different types of geometry, such as what we see here. This includes all of the train car geometry, as well as the doors and the portals themselves. The way that MassMotion works with collections is it is intelligent enough to realize that when we're discussing our vehicle origins and we select this collection, it's only selected the portals. In order to see within a collection what is being chosen, you will see the period or the full stop and then the type of geometry that is being selected. So what this says is that for each one of our headways on our train, our eastbound train, we have these portals here which are within the eastbound train collection. And then in a similar fashion, we send them to our neighborhood exits portal, which has a defined manual waiting list. In terms of boarding, we can set up a simple system for agents moving towards the train. In this particular example, this is governed by the journey which we've previously set up. But in order to quickly run through, we can have a look at the pre-arrival time. We also have the same origin and destination list as in the alighting system. It is worth noting that if we set the timing before our boarding agents to arrive to be prior to the simulation start, these agents will not be created. So this is something to keep in mind. We'll disable that for the moment and then have a look at how these eastbound trains system actually runs. Now I've run a previous simulation, so we already have data within the scene. What we see here is people will alight the train based on our headways and then move across the links and head towards their neighborhood portals. We can also see that there are some boarding movements who will not be able to enter the train until our vehicle doors are open. We also have on these links priority set such that these agents will wait for alighting passengers to exit the train before they enter. In a similar fashion, we have the westbound trains set up on a separate system of timings with another vehicle event, and we also have our similar system going on with our bus. So this gives a brief overview of the vehicle event, which enables creation of quite complex geometry. Thank you.